Okay, guys, here we go. Algebra 2, Chapter 13, Section 1, and the homework page is going to be on 876. What we want to do today is learn about trigonometric identities. We're going to try to use trig identities to find trig values and simplify expressions, okay? So first we're going to talk about trig values, and then we can try to simplify expressions later. So a couple of things you need to know. Maybe you already remember. Okay, hopefully you remember. Sine and cosecant are reciprocals of each other. Sine, cosecant are reciprocals of each other. So if you know sine and you flip it, it becomes cosecant, and vice versa. If you know cosecant, you flip it, you become sine. Same thing with cosine and secant. Flipping cosine gives you secant. Flipping secant gives you cosine. Tangent, same idea. There's three basic identities that we need to know. Cosine squared plus sine squared is always equal to 1 for every right triangle, no matter what size it is. Okay, every right triangle, cosine squared plus sine squared always equals 1, regardless of the angle. So from here, we can find two other identities, and that one is tangent squared plus 1 equals secant squared, and the last one, cotangent squared plus 1 is cosecant squared. So when you're doing these problems, I would always recommend you identify what x, y, and r is for each problem, and then identify the proper trig that they want you to find. Okay, so we'll do some examples. Okay, let's figure this out. So let's say, for example, they tell us that secant equals 2 in quadrant 4. Okay, secant is 2 in quadrant 4. And they want us to find sine, cosine, and tangent. So here we go. Secant is 2, but 2 is the same thing as 2 over 1 as a fraction, right? You remember that 2 is the same thing as 2 over 1, but we normally don't write 1 here. But we know it's 2, 2 is 2 over 1. So remember, secant, if we flip secant, when we flip secant, it becomes cosine. So in other words, when we take 2 over 1, we flip it, we get 1 over 2. Okay, so right there, this is easy to deal with, and it allows us to graph and identify x, y, and r. Okay, so remember now, we're in quadrant 4. Now, cosine is 1/2. So what does that tell you? Cosine, remember, cosine is x over r. So that tells you x equals 1, r equals 2. Good. Okay, Pythagorean theorem, x squared plus y squared equals r squared. 1 squared plus y squared equals 2 squared. So 1 plus y squared equals 4. Bring the 1 over. Y squared equals 3. Okay, so y equals plus or minus. Every time we square root, we have to plus or minus. So square root of 3. Now, remember, we're in quadrant 4. Since we're in quadrant 4, is the y going to be a positive radical 3 or a negative radical 3? Okay, so that's what you have to ask yourself. And we remember quadrant 4, y is negative. So we say y is negative radical 3. So now we have x, y, and r. We can graph it out if we want. Starting from the origin, we go right 1, 1, down negative radical 3, and then go back up to the origin. Okay, so this is 2. Okay, so here's our angle. We actually know this degree is 60 degrees. So our total angle is 300. Okay, we learned that already in the past. But what they want is sine, cosine, tangent. They want to know what are these three values for trig. So we say sine of this angle, which is 300, okay? So sine 300 is y over r, okay? Y over r. So we know y is negative radical 3, r is 2. There we go. So that's our sine value. Cosine is 1/2. We found that earlier already, so we're good. Tangent. Tangent, if you remember, is y over x. So negative radical 3 over 1. And we normally, when we're done, we always simplify. We never leave a 1 in the denominator, so negative radical 3. There we go. We found all three trigs that they wanted. Okay, there we go. Okay, do another problem. Okay, so for example, they tell us that cosine is -1/2 in quadrant 2. Okay, they want us to find, let's see, tangent and sine. Tangent and sine, okay? So let's think about this a little bit. Cosine is what two letters? X and R in quadrant 2, right? In quadrant 2, so keep that in mind. So that means X equals -1, R equals 2. So Pythagorean theorem now to find Y. Okay, so we have -1 squared plus Y squared equals R squared. So 2 squared. 1 plus Y squared equals 4. Bring the 4 over. Y squared equals 3. So Y equals plus or minus square root of 3. Because we square root, we have to plus minus. Now, be careful. Think about this. We're in quadrant 2. In quadrant 2, is the Y positive or negative? In quadrant 2, Y is a positive radical 3. Okay? So now we can find tangent easily. Tangent is Y over X, positive radical 3 over -1. And so just simplify that, right? Negative square root of 3. Sine is Y over R. So radical 3 over 2. And then that's our answer. We can't simplify anymore. All right, that's it. That's our second example. Okay, we'll do one more example on finding trigs here. Okay, so this last example on finding trigs is they tell us tangent is equal to -5/12. Okay, in Q2. Find sine, cosine. Okay, tangent has two letters, Y and X. Good. Okay, now, in quadrant 2, is it possible that Y equals -5? Okay, well, in quadrant 2, Y is always positive. In quadrant 2, Y, right here, right, in quadrant 2, Y is a positive number. So how come this says -5? So what happened was the negative really belonged to the 12, and they moved it up to make it look proper. Okay, but you don't want to get tricked. So remember, Y is positive. So what this means is that this actually has Y value of 5, X of -12. Okay, we never write a fraction with the negative sign on the bottom, and so that's what they did. They fixed it. And so let's find R. Okay, -12 squared plus 5 squared equals R squared. 144, 25, R squared. 169 equals R squared. We square root this, both sides, and 13 equals R. You don't have to worry about R being positive or negative. R is always positive. R is a distance. Okay, so R is 13. So what does this mean? This means our triangle goes left 12 units, -12, goes up 5, and has a diagonal of 13. Okay, so no big deal. This is not a famous angle, so we don't need to know what the angle is, but they want us to find sine and cosine. So sine is Y over R. So we look at Y. Y is 5, R is 13, and that's our answer. Cosine is X over R. So X is -12, R is 13. Voila, that's sine and cosine. Okay, so make sure you try examples on those. And then there's two examples where we're not doing that. We're gonna simplify these trig expressions, okay? Sine times cosecant minus sine. They want us to simplify this, make it look better, okay? Simplify as much as you can. Sine times cosecant minus sine. Okay, so if you remember this is 1 over sine. Okay, so really it's sine, parentheses, 1 over sine minus sine. Okay, so there's two things you can do here. You can distribute this. Distribute. What's sine times 1 over sine? Sine times 1 over sine is 1. Sine times sine is minus, right? Sine times sine is sine squared. Okay, so 1 minus sine squared, we got to try to simplify that. Okay, if you remember the very first identity that we looked at is cosine squared equals, plus sine squared equals 1. And we bring this over by subtracting sine squared. We get cosine squared equals 1 minus sine squared. So that's what this guy is. So this tells us that this equals cosine squared, because cosine squared equals 1 minus sine squared. So we simplify this. We took this original expression, looks kind of complicated, has a couple of trigs involved, and we simplified it to be cosine squared. That's it. Okay, last example. Cosecant minus cosine cotan. Okay, so we're going to try to simplify this. Now, what is cosecant? Cosecant is 1 over sine minus cosine. What's cotan? Cotan is the reciprocal of tangent. So take tangent and flip it. Tangent is sine over cos. And when you flip it, you get cotan. And this is cosine over sine. So we get cosine over sine. Okay, so now simplifying this, we have 1 over sine minus cosine times cosine, which is cosine squared over sine. Now, if you notice, both denominators are same. Since both denominators are the same, I'm going to put it together as one fraction. Sine on top would be 1 minus cosine squared. Now, what is 1 minus cosine squared? If you look at the original identity here, cosine squared plus sine squared equals 1, right? If I bring this over by subtracting cosine squared by subtracting it, I get sine squared equals 1 minus cosine squared. Basically, what this means is that you can substitute. Anytime you see a 1 minus cos squared, it is this. So you can replace 1 minus cosine squared with this guy. So in other words, I can take this out and I replace it with sine squared over sine. Now, sine squared over sine is this sine times sine, and I'm on the bottom of sine. So I'm going to reduce, and this is just sine. Okay, so we took a problem that had 3 trigs in it. We simplified it just simply to be sine. All right, so try that on your own. Good luck on that.